Hello, my name is Ben Peecher. Thank you for your interest in my poster. I've been working with Dr. George Miley on low-energy nuclear reactions in metal hydrides. So we hypothesize that you can overcome the Coulomb barrier by, in a metal hydride, densely packing hydrogen into a crystal defect. You heat up the reactor, this heats up the hydrogen, they bounce around inside the crystal defect. It's densely packed enough with hydrogen in there that there's nowhere to go except for where their hydrogen is, and hopefully you'll see fusion. So we manufactured an amount of palladium zirconia with a high density of these crystal defects and loaded them into a reactor, which you can see in figure 2, the particles and the reactor. And then we ran a series of experiments with the goal of creating and observing low-energy nuclear reactions, LENRs. Our method of observing LENRs is calorimetry. So that's heat out minus heat in equals excess heat. Any amount of that excess heat that you can't explain by other heat sources, we're attributing to low-energy nuclear reactions. This method of calorimetry gave us results that were difficult to interpret. The way that we got our heat out signal was converting the temperature signal to a heater input power signal. That's going to be the heater input power required to get the reactor to said temperature. And just the uncertainties in our integration method were too great to give us results that were very useful. I get into those difficulties under data analysis if you want to know more. And our attempt to salvage the data was performing an analysis of variance, get a little bit more of a useful conclusion from these experiments. So the question is, do we see more heat than you'd expect when you'd expect to see LENR? So that's when three variables are in the right circumstances. A, are the particles reactive or unreactive? Reactive. B, is the gas reactive or unreactive? Reactive. And C, is the reactor pressurized or not? We want it to be pressurized. So is there a positive covariance of those variables? The answer is yes. We do see more heat than you'd expect for reactive particles, high pressure, and temperature. So those three variables are positively covaried, but statistically insignificantly so. It's possible that we could prove this excess heat through greater data collection, but the amount of excess heat here is pretty small, and we're interested in ultimately creating a power source. So that means creating larger volumes of LENR. So that's what our future work will be focused on, is experiments where we're hoping to see LENR in higher volumes. We're testing this by introducing catalytic mechanisms to the reactor, such as high voltage sparking, magnetic field pulses, etc. And that's going to be the future of the project. That concludes my poster. Thank you for listening.